Hello friends, I'm Ram Lakshmanan, architect of Ycrash. In our earlier video talk, we spoke about the architecture of Java virtual threads. So in this talk, let's discuss about what are the APIs that is available to create a Java virtual thread, right? That's what we're going to be discussing in this video. Okay. So friends, at the time of recording this video, that is January 2023, this Java virtual thread is available as a preview feature in JDK 19. So what does the preview feature means? A preview feature means this APIs, what is there, can be modified or updated in the future releases. So there is a chances that these APIs, what we are talking now, may be updated, but most likely it may not be also, right? So now, equipped with this disclaimer, let's go forward, right? Okay. The first and the most easiest way to create a virtual thread is using this start virtual thread API, which is available in the Java lang thread class, right? So the start virtual thread takes in a runnable as an input, right? So here what I'm doing, here I'm creating a runnable task, which is written as a lambda expression, right? Here is a runnable task, and here's a run method, the implementation of a run method, right? It says allow virtual. For some people who are not familiar with lambda expression, say if I'm writing this lambda expression in unfolded format, this is how it's going to look. So here is this task which implements a runnable. It overrides this run method. Here it has this allow I'm virtual thread. So this is a runnable task, and you can pass this as an argument to the start virtual thread. When you do this, then the virtual thread will be launched, and then this task will be executed using a virtual thread, not by a platform thread, right? Okay. So this is one of the easiest way to create a virtual thread. And here is a second approach to create a virtual thread. That is, here you can see, I can use this one, Thread.ofVirtual, and then start passing a runnable to it, right? This is all just another API to create the virtual thread, which is very similar to the earlier option that we saw. And now there is another option to create a virtual thread. Here it is called as Thread.ofVirtual unstarted, right? Look at this. What does this unstarted mean? See, here I'm saying vThread.ofVirtual unstarted, and I'm passing this task. So when I do this, what happens is the thread is not, virtual thread is going to be launched immediately. It's going to be launched only when I'm going to invoke the start method on it, right? So why do I need this? Why do I need this approach? Okay, see on line number 4, you're creating a thread object, but I'm not launching it. I'm launching it only on line number 5. But whereas after this line number 4, what I can do, after the line number 4, I can say if I want to set a name to this thread, if I want to set a priority, I want to set some attributes to the thread, I can do that. And I can do all those, I can set all those attributes, and then I can say start. And now the thread is going to get started. Okay. So this is the third option. A lot of you may be familiar with the executors, right? Executors is a very powerful mechanism to create, manage, and shut down a thread pool, right? Executor has a thread pool and it has some queues to it, right? It's a sophisticated mechanism. So using executors, in the executors also, you can create virtual threads, right? So this is how you can do. In the executors, you can say new virtual thread per task executor. So when you invoke this, what it's going to do is you are going to create a new virtual thread for every new task that is submitted to this executor, right? So unlike in the platform threads, whenever the executor is used, it has a finite, you have to define, oh, what is my min and the maximum number of thread pool size, right? Whereas here we can say, I'm creating a new virtual thread for every task, right? Because virtual threads are very lightweight, as we discussed in the earlier architecture, right? When they're not executing, when they're just waiting, they're just stored as an object in the heap, right? Which occupies very minuscule memory. So in fact, it's recommended for every task, you create a new virtual thread, let it execute, and then let it die, right? So this is that. And the fifth option is, this is a minor variation to the fourth option that we discussed. Here, what I can do, here also I'm creating task executor, but here I'm passing a thread factory as an argument. right? What does this thread factory does is, so in the thread factory, it gives me a flexibility, like I want to set a name, give a name to each of my thread, right? I can do those kind of stuff here. I want to set some attributes to my thread. I want to set a priority, name. So all those things I can do with the thread factory. And I'm passing the thread factory as an argument. So now whenever a thread, whenever this executor wants to create a virtual thread, it's going to first invoke this thread factory, and it's going to set all the attributes, and then the thread executes its job, right? So friends, these are the 5 different options that is available in JDK 19 today to create a thread, right? So in the description, I'm going to be sharing what are the, in the other video clip links where we are going to be talking about, where I have spoken about the different approaches, what is the architecture of virtual threads, what are the benefits of it, what are the performance impact, and what are the pitfalls you want to look at avoiding, right? So thank you, friends. So then everyone for watching this video clip.